Hey everyone, and welcome back to another tutorial. I'm Mohammad Hassan, and in this video series we are talking about data structure and algorithm, which is an integral part of being a software engineer because you get to implement it somewhere in your career. In this particular video, we are talking about how to implement queue data structure into JavaScript. So we are going to have a look at the JavaScript example as well as some UI that you can use to visualize how a queue works within JavaScript. If you want to connect with me, just follow on my socials, and if you have not subscribed to the channel, do it right now because it helps the channel grow and we can provide free content throughout the world. And now without further ado, let's start. So first of all, if you don't know about the repository yet, you need to go to github.com/snirs, and then you can go to the repositories and you can try to find the repository with name Fun with JavaScript. This is the one that you need to clone. If you go here and click code, you should be able to get the repository. You just copy it, then you go to your terminal and just type git clone and the repository link, and then you should be able to clone it into a project. Once you are done with that, you can just say npm install, and then this command should install all the packages required for this project into the node module folder. Once you are done with that, you need to run the npm start command. And when you do that, it will essentially start up the webpack server, and also it will also serve this whole directory or the this directory into localhost 8080, and then you can just go there and open any examples that are within this repository. So right now we have JS stack example and JSQ. So since I've done this, I can go to my browser, and here I can open http localhost 8080, and here I should be able to see the index of all the projects. Now we already worked with the stack project previously, so here we can have a look at that. So as we discussed, the stack is something that uses the last in first out principle, which means that if I add 3 items, the last item I pushed was 25, and if I want to take out one item, 25 would be that item. So if I take it out, you can see that 25 is out now and we are remained with 38 and 3, and then this goes on. Now we're going to talk about how stack is different from queue, or how queue is different from stack, in just a bit. So on this Miro dashboard, we have an example of the stack and queue. So imagine that we have these 4 elements that we want to push to a stack. Since stack follows a last in first out principle, that means that if I'm going to put, let's say, the value 1, so I'm going to just drag this 1 here. Now this is the first item that was pushed to the stack. Then let's say we push 2, then we push 3, and then we push 4. Now 4th is the item which was pushed last. So stack follows the principle of last in first out, which means if I have to put out an item from this stack, that can only be this 4 element, which is the one that we pushed last. And then the first item that we pushed, it's going to be the last item that goes out. So now I have to remove 3, now I have to remove 2, and now I can remove 1, and that is how stack works. Queue on the other end is sort of an opposite of this one because it uses the first in first out principle. In this case, let's say if we have 4 elements 10, 20, 33 and 44, and if we push this in a sequence like this, first 10, then 20, then 33 and then 44, then the way it would come out would be 10 would be the first item to come out, then 20, then 33 and finally 44, because 10 was the first item to go in and 44 was the last item. So for a stack, imagine that you have a stack of books, which means that you put one book on top of another. And if you have to see the title of a particular book, you only can see the title of the topmost book, which you put last. So if you have to remove a book, you have to remove the most recent book that you put, which was the last item to put, so you can take it out. And the first item that you put as a book, you can only take it out as the last item when taking out. So that's an example of a stack. With queue, it's like when you stand in a line for, let's say, in a bank. So the first item who goes into the line is the one who comes out of the line, and the last person who got into the line will be handled last. So that's concept of the queue. Now that we know a bit about stack and queues, we are going to see how we can implement that in JavaScript. If I go back to my localhost 8080 and if I press back, I'm back to my project's root, and now I can go to JSQ. So I already have some things implemented here. For instance, we have a queue here, and then we also have some buttons for adding item to queue, taking out an item, peeking to the queue, and clearing out the queue. When we talk about peeking a queue, that means that we are looking at which item will come out of the queue if we wanted to remove it. In the case of stack, that is always the last item that you push. So if we had 1, 2, 3, and 4 in this sequence, then 4 is the item that is going to be peaked at, because that was the last item that was pushed. But in case of putting 10, 20, 33, and 44, when we peek into the queue, we will find always the first item or the oldest item that is in the queue. So if I remove 10, then the oldest item is 20. So this one is the one that is going to be taken out if I have to remove something from the queue. So now that we have the UI in place, let's have a look at some coding details. So right now in the code, I'm actually at the JS queue start branch. If you want to follow along this video, you can just check out this JS queue start branch by just typing git checkout, and then you can type JS queue start. And by that, you will switch to the branch, and then you will have the same code as I'm showing you right now. So the first thing that we need to look into is the source folder, inside which we have the JSQ project. And inside here, we have the queue.js. This is where we are going to code all of our work. Now this one already has an implementation of the queue class, just like we have for the stack class. If I open main.js here, you will see the stack class is exactly the same as the queue class because I just copy pasted the code. But essentially we are going to remove all of this, and then we are going to start from scratch to understand what's happening around this value. So one of the things that I would change is rename this takeout method to remove, just to establish this terminology that we add items to the queue and then we remove items from the queue. When we add an item, it goes in, and when we remove it, the first item that we put in the queue should be taken out as well. Now, in order to save the items, in the example of stack, we used an array that we called items. Here, we are also going to basically use items as a variable, but instead of an array, this would be an object. So we are going to handle object for this queue. Now, we need to know that when we add an item, which key should we assign to this item. For instance, an object can have any key, or let's say call key1, and it could be a value here, and then there could be a key2, and then I could assign a totally different value here. In order to just save the items here, the keys that we are going to use will be indexes, or will start from 0 and will move forward. So I'm going to use the keys just like this, just to kind of mimic it, similar to being an array. And I'm going to tell you the reason for that, because it's really easy to manage it this way with some additional variables. So I'm going to make this empty again now. And the first thing that we need to know is at which key the next item is going to be added. So for that, we are going to create a property, and we could say item to add index. And that would be initially 0, because 0 is the first key where we need to add an item when the queue is absolutely empty. Now, in order to add the item, what we need to do is we will just say this dot items, and then for the index or for the key, we are going to provide item to add index, or actually let's rename this to key. So we are making sure that we are using the right terminology. And then here we can say item. Now, once we do this, we now have to think about where the next item would be added. So in order to do so, I'm just going to increment this key value. So now the next item to be added would be at the key 1, and then the list goes on. So these are the two things that we absolutely need to do for adding an item to the queue. Now let's talk about what happens when we remove an item from the queue. For that, we also need another identifier or a variable, and we are going to call that item to remove key, and we are going to initiate that with 0 as well. Now, in order to remove an item from the queue, we need to check if we have the queue as an empty queue or not. So to check that, we can simply say if this dot is empty, and we don't have the implementation right now, but don't worry about it. So if the queue is empty, then we are going to return undefined. And the reason for that is that this remove method is supposed to do two things. The first thing is it needs to delete the object or the item within the items object at the particular key which is to be removed. And the second thing it needs to do is to return the removed item. So first we need to actually identify the item to be deleted. So what we are going to do is just save that item before deleting it from the items object. So we are going to say item, and then here we can simply say this dot items, and here we are going to use item to remove key. Now this will basically get the item that we want to remove from the queue, which should be the oldest item pushed into the queue. And then we will just say delete this dot items, this dot item to remove key. This particular line will remove that item from the queue. So we are getting rid of that. But then we also return the item. So we should do return item. And that's pretty much about it. One more thing that we need to understand is that considering that we have 3 items in the queue and the first item is at index 0 or key 0, that means that once we have removed the item, we should now think about what is the next item to be removed. So in order to handle that, we need to increment item to remove key. So I can just do this. And now we are handling both use cases pretty well, adding an item and also removing an item. Now let's talk about clearing the queue. So in order to clear the queue, we can simply say this dot items, and then we can assign it to an empty object again. And then we are going to reset these two values as well. So we are going to just say this dot item to add key equals to 0 and this dot item to remove key equal to 0. So we are sort of resetting the keys right there. Now the next thing that we need to handle is how do we calculate the size of the queue, which should reflect how many items are there within the queue. And we can easily calculate that by just subtracting the item to remove key from the item to add key. So we can say return this dot item to add key minus this dot item to remove key. And this should return the size. Now in order to check if a queue is empty, we can simply say return this dot size. So we are going to get the size and then we are going to check if it's 0. So if the size is 0, we know that this is an empty queue that we are talking about. And when talking about peak, this is only going to look at, which means it will return the item that has to be removed. So we already are handling it here. So I'm going to just return this value from the peak method. So we can simply say return this dot items and then item to remove key, and this should return the values for us. Now that we have this code entered now, we are going to essentially just have a look at some examples and then we are going to check if it works. So what I'm going to do here is that I'm just going to create a method. So I'm going to call it const main, and here I'm going to do some magic, and here I'm going to call this main method. So it is called and executed. And now I'm going to create a queue here. So I can simply say, hey, const my queue equals, and then we are going to create a new queue here. And then we are going to do some operations within the main method for this. For instance, I could say my queue.add. So we are going to add some items here. We are going to add 10, and then we are going to add, let's say 20, and then we are going to add, let's say 33. So now we should have 3 items in the queue, and then we are going to remove, let's say 1 item. So we are going to just say my queue.remove, which should essentially remove the first item, which is 10. And then we are going to check a couple of functions. So we are going to check if the queue is empty. So we can simply say console.log my queue dot is empty. And there I'm going to add some labels as well. So I can simply say is empty. And here I'm going to use this variable. I'm quickly going to copy paste this a couple of times to check a couple of things here. Then we're going to check the size of the queue by using the size method. And then we are going to use the peak method to have a look at the item to be removed next. And then we are going to just log the whole queue as it is. So I'm going to just log this as it is. Now let's save this and let's try this on the browser. So if I refresh now and open the Chrome Devtools, we see that we have an error. Let's fix it. So I'm here and I can see that this is wrong here. This should be this dot item to add key. Now let's save this and try this out. So if I refresh now, you can see that we landed on the main method. I'm going to go inside. Right now, you can see that my queue has 0 items, which means the object is completely empty. We have the item to add key at 0, item to remove key at 0 as well. Now, once we add an item, you can see that my queue has updated the item to add key, which means the next item is going to have the key 1. And you can see that right now the item that we have has the key 0. Now the item to remove key is still 0 because this is the item that should be removed whenever we remove an item from the queue in this current state. Now we add one more item and you can see that now the item to add key now is 2 because we already have 0 and 1 in place. So the next item should be having the key 2. The item to remove key is still 0 because even now, if we have to remove any item from the queue, it should be this one, right? So we move forward and then we add the value 33 as well at index 2. The item to add key becomes 3. And now we are going to remove one item from the queue, which means that we should be getting rid of this one, which is at key 0 and the value is 10. So if we remove, you now should be able to see that now we have the 0 key and its value removed, and now we have only 1 and 2. And now you can see that we have item to remove key also updated by 1. So now it's 1. Now let's talk about checking is empty and size and whatnot. So if we check the log for is empty right now, you can see that the is empty is false. And the reason for that is obviously we have items already in the queue, which is with key 1 and key 2. Now we are going to check the size, and the size that we have is 2 because we have 2 items in the queue. And I already told you that the size is calculated by subtracting this item to remove key from item to add key. So you can see that 3 minus 1 results in 2, and we have 2 items in the queue. So that makes sense. Now, when we talk about peek, this method should return the next item to be removed, which means that if I have a look at the items, this item with key 1 and value 20 is the one that should be returned by this method. So if I go over this one, so if I check on console, you can see that the value is 20, which is on the index 1 as we just discussed about. Now, if we just log the whole queue, if we check the queue, you can see the exact queue that we just talked about with just having 2 elements. Now that we have the queue working perfectly, we need to kind of integrate this with the UI so we can visualize what's happening. So what I'm going to do is that I'm going to implement a method that is going to render all the elements in the queue into the view. So I'm going to use a pre-made snippet here. And this is a method that basically renders all of the item in the queue to the UI. So I'm going to call this method after the logs actually. So I'm going to just call this here, and let's see what this does. This basically gets the box, which is this box that we are talking about, the outermost box. Then it removes all of the items that were previously rendered. So whenever we render, we start with a clean slate. Then it goes to the items in the my queue or the queue and then runs a for each on this one. Now this code was copied from the stack example. So this will not work because items itself is an object, so it cannot have the for each property. So what we need to do is we can simply say for const key in my queue dot items. So we are just running a for in loop here, and then we can say const item equals my queue dot items, and then here we can say key. Now this should return us, or this should get the current item in this iteration, and then we can just move this whole code here and then remove this, and this should do exactly the same thing as we discussed. So if I refresh now, you should be able to see that once we are through all this step, we have the remaining items which were in the queue added to this JS queue. Now this looks a bit weird because it is not in the order that we would want. And why? Because if I expand this, you can see that we should have this 20 before 33. So 20 should be up and 33 should be downwards. So in order to fix that, what we would do is that instead of this prepend method, we are going to use the append method. So they are in the right sequence of the queue. Now if I refresh and kind of move this breakpoint, you can see that now we have 20 and 33 as we have in the queue in the right order now. Now these items are currently being shown at the bottom of this queue. So what I want is to essentially move this to the top instead of bottom because it's visually a bit better. So what I'm going to do is that we already have this JSQ CSS file that we have to import into the queue.js. So here I can simply say import, and here I can say jsq.css. And once done, I can save and try out. So if I refresh now, you can see that now we are showing this at the very top. And now we have this, at least from the UI perspective, completed. Now we are going to implement one more method, which is the peek method, which will essentially just highlight the item that is to be removed next. So what I'm going to do is just add another snippet here. And now if we have a quick look at this method, what's happening here is that it essentially goes into the queue and then picks up the first child, and then it adds a class to it and then removes a class, which sort of gives us an animation kind of feel. So what I'm going to do here is that once we are done with adding, removing, and rendering, then I'm just going to call this PQItem method. So we know that we have the next item to be removed as this particular element. So if I refresh now, you should be able to see that we are highlighting this 20 item as the element to be peeked, or as the element that will be removed the next time we remove something from this queue. Now let's quickly add different handlers to all the buttons that we have in the UI. So you can see that we have the add item button. I'm quickly just going to change this to remove item, and then we have peek, and then we have clear. So we have all these buttons here. Now I'm going to quickly add some snippet to add handlers to all these methods. So this is the function that we are going to work with, and it's a really easy one. I'm going to tell you what it does. So this initiate handlers method basically gets all of the buttons, and then it attaches a click handler to all of the buttons and basically performs actions according to what they should be doing. So for instance, for the clear button, you can see that we do a myQueue.clear and then we render the queue again. Similarly, for the add item button, we essentially generate a random number, and then what we do is that we add that item to the queue and then we re-render the queue. Similarly, for the take out item button, which is the remove button, this basically removes an item from the queue. This should be remove, and then it re-renders the queue, and then it peeks the next item to be removed as we discussed. And for the last peek item button, we just peek the queue item which is to be removed the next time we want to remove something. So now that we have all this code here, let's just call this in the main method. So here I'm just going to say initiate handlers, and that's pretty much about it. Now if I refresh the page, we can add items to this queue. So I can add more items. As you can see, they are going downwards, or they are being added to the bottom for each particular item. And then if I peek, you can always see that it is the first item that is being peeked. Now if I remove an item, you can see that the 20, or the first item, that's gone now. We have 33 as the item which is supposed to be removed next. So if I do peek, you can see that it is highlighted. If I remove this, then 13 would be the next item to be removed. So if I remove this, you can see that 13 is being highlighted, and this goes on and on and on. And if I add a lot of items, I can quickly clear the queue by just pressing the clear button. It clears the queue and then it re-renders all the queue items which are none. So we don't render anything in that particular case. So now you can see how the queue works in JavaScript, and I hope that this now makes sense more visually than just looking at the console. Awesome. So I hope that you liked the video. If you did, press the thumbs up button. If you have not subscribed to the channel, do it right now. And type in the comments what data structures or algorithms you would want me to cover in the next videos. And also let me know if you found this video useful or not. It was a yay or nay. And as always, happy coding. I'm going to see you in the next video.